Hello, everyone. This is a technical walkthrough call with Nethermind, one of the projects which are part of the upcoming, or actually already live, Ethereum Attackathon. By the time you're going to be watching this video, the Ethereum Attackathon is going to be live. For those of you who missed it, the Ethereum Attackathon is going to go live on November 25th. So very, very soon. And then it's going to last till till January 20th, 2025, up to 1.5 million in rewards. But we're here for the Nethermind story, Nethermind's code base and little secrets. So we're here joined by Ahmed. Ahmed, thank you so much for joining. And please take it away with the
No problem.
presentation and everything. Thank you so much.
Thank you, sir. So I will start with sharing my screen. I'm using Rider here to look at the Nethermind code. Of course, Nethermind code is written in C#. So C# is a programming language that is developed by Microsoft, as far as I know. And we have built Nethermind on .NET. It's a client that is compatible with any operating system and can run on almost any platform. So it runs on Windows, Linux, and Mac with flavors, and can also run on x86, it's x64, and also ARM based systems. So yeah, so let's start with the project structure. So in Nethermind, let's start with one thing, which is the Nethermind runner. This is the application that starts Nethermind, right? This is the application that starts it up, sets it up, and sets up all the things that are required to run the node. So this is the startup project. So, and I will from here go all the way down to Nethermind core. So this is the very core of the blockchain. This is where we define classes like address, like account, and block, etc. So these are the very basic classes that are used in the node to form the blockchain. Transaction types, transactions, blocks, um, uh, and addresses, accounts, etc. All of these kind of stuff, you can find it in this project. So this is a very critical project. It's like the domain, like the thing that has all the objects that hold everything together. Um, right. So that's one. And then we have also the Nethermind blockchain project. This is where we have our block tree. And yeah, so this is where we have our block tree, our chain head, uh, our Genesis loader, all the stuff that form the chain itself. So now we're not talking about base classes, we're talking about chain and like the abstract above it, and all these kind of stuff. So also the spec, for example, the spec of the chain, um, the etc. All these the block stores where we store the blocks, um, and yeah, these kind of things. And then I will move on to Nethermind crypto. This is where all the cryptography stuff happens, right? So here we have the ciphers, we have the algorithms, the signatures, the curves, the ACDSA curves, the CISP curves, the all of these things, the Blake 2 implementation, all of these things. You can find them, anything related to cryptography, you will find here. The Kitcheck 512, for example, etc. Additionally, you will notice that there is some dependencies here, and you will notice that there is a library, a couple of libraries that we use. Some of them, so some of our code is dependent on external libraries. So bugs in these external libraries could lead to potential bugs in our code. Also, some of the libraries that we use, we export them as NuGet packages so they can be reused in other projects. So if you look at core, for example, let's look at the dependencies, and we can see that, okay, we only depend on um, Okay, so we depend on something called CISP 256, 256K1. So this is a cryptography library, and this is we export it because it's used in multiple places. So we export it. So we can go and check this particular library code on GitHub and know if there's anything critical on it. There is also the int 256 library, for example, where you can find a lot of math operations that happen here. And all of this code is like our code depends on these libraries and these things. Moving on back to the code base, we then have the consensus related projects. So we have Nethermind consensus, and this is where the validation and calculations happen, the mining, the signing, the sealing, these kind of stuff. Uh, Withdrawals are processed here. Blocks are processed here. So the block processors, transaction processors are probably here as well. Yep, transaction, uh, validators, processors, filters, etc. Yep, you can find the validators here with the transaction validator and the executors, all of these. And so this is the consensus. And of course, consensus here has multiple algorithms. So because Nethermind supports multiple algorithms, so we support Aura, and we support Click, we support ETH which is like deprecated now. Nobody's using this as far as I know. And we also have the Nethermind plugin for the merge, because like the way we implemented the merge, we implemented it as a plugin on top of Nethermind. And this is why we have the merge, which is part of consensus, but as a separate project under the plugins merge uh, directory. And here you can see we have also like the engine API stuff. We have the merge configs, um, merge processing, etc. POS switcher, so switching from proof of work to proof of stake, all of that, synchronization using beacon headers, and these kind of things. All here, handlers of different calls, and a bunch of objects that are used for the engine API, etc. And then there is also the block production parts that are needed after the merge. Given you get the fork choice and the payload attributes, you need to do block production here. So this is all the stuff that is needed for that. Moving on, you also have so one thing about still that is part of consensus that is very important, which is EVM. So the EVM implementation for Nethermind is located here, and you'll see all the transaction processing classes here, and then there is also the Ethereum virtual machine. This is the most important class almost in this in this code base. This is where we have the logic for executing all the bytecodes, different bytecodes of Nethermind, right? And of course, like, so bugs in general in these components that I have mentioned. So from Nethermind core to Nethermind blockchain to Nethermind block crypto, Nethermind consensus, Nethermind merge plugin, Nethermind IVM, all of these yet I haven't touched on some important ones like serialization. So we have the RLP serializers here that serialize blocks and transactions, etc. So all of these, the things that I mentioned just now. Oh, there is still one more that is important to mention, which is the trie. So this project has all of the Merkle tree classes. So the trie nodes, the nibbles, the nodes, storages, the trie itself, the Merkle tree itself. I mean, all of that is the Patricia tree here. All of that is in this project. And all of these projects that I have just mentioned to you, these projects are like like the most critical ones in my opinion, because they form what we call consensus. And if a bug is found in these projects, that means that someone could potentially exploit it and create a fork in the Ethereum network. So all people who are operating Nethermind would fork because of this particular bug in these projects. So this is very serious. These are very serious, and we have like very rigorous um, review process for them when we make changes on these classes, right? Now, other than that, there is also other important classes, like for example, network stack. So the P2P network stack, where we have the discovery, so disk v4 and disk v5, where we have the DNS for discovery, the ENR, also, and where we have the so all of these, this is where we have the P2P subprotocol, the ETH subprotocol. This is the protocol that is used for syncing. There is also the Snap subprotocol for Snap syncing, etc. And there is the Node Data subprotocol, etc. So all of these are spec'd here in the Nethermind.network class. And of course, oh, by the way, I mentioned Merkleization because I mentioned the try. I thought I mentioned Merkleization, but there is also Nethermind Merkleization. Sorry, it's not that arranged. I'm going all over the place. So yeah, and other than network, you have another thing that you need to be mindful of, which is JSON-RPC. So JSON-RPC, this is where we expose the modules like ETH module and the debug module, so they can receive Web3 modules, so they can receive requests. And these requests are like RPC requests, like ETH send raw transaction. This is where you send raw transactions. This is where you connect your wallet, right? This is where the wallet connects to and like gets information from the node about what's happening on the blockchain or certain account balances, etc., stuff like that. This is also where you can manage the node using admin RPC. The debug module, as I said, gives important information sometimes. Web3 module is used by a lot of wallets, etc. And then the proof module is to generating proofs, is very important for validity proofs of information. So yeah, there is a bunch of modules that we expose in the JSON RPC, and this is the project that holds them all and has all that logic. So if you look at these projects that these are, oh wait, before I summarize these projects, there is also the synchronization project. This is where the sync logic is. So you saw that we have the network stack where some of the sync messages are located and the protocols for syncing are located, but the sync logic is located in here. So the synchronization logic is here. So for Snap Sync, you can look here. For managing the peers, you can look here. There is the fast sync for syncing headers and bodies, fast blocks as well, etc. All of these are here in the synchronization project. And it seems that I have brushed over the state project, because the state project actually is part of the consensus as well. So if we go to the state project, the state project basically uses the tree. So it sits on top of the tree. It's an abstraction on top of the tree where all of the state for the client is located, right? So this is where that is located, and this is part of consensus as well. So it's a very critical project. So yeah, so like going back to synchronization and network and JSON RPC, all of these are important also to look into, because they have the potential to contain DOS vectors attack, because someone could potentially use the P2P protocol to DOS Nethermind clients on the network, and this would lead to a lot of the Ethereum participants to go offline because of this DOS attack. So this is very important as well. So if someone has his JSON RPC exposed to the public, which is not normal, this is very rare. So this is not like a real attack. But the attack that's very critical is mostly around the P2P protocol, the network stack. Yeah, this one, and RLPX, sorry, etc. These kind of things. These are very critical. So yeah, this is a quick run. Oh, there is also the transaction pool, of course, because someone could potentially keep sending transactions to the transaction pool, and then the node runs out of memory. So if someone can potentially find like a loophole where they can keep spamming that transaction pool with transactions, that could lead to a DOS vector as well. Yeah, of course, you have some projects about DB. So like the things that the state and the trie sits on top of. Um, but yeah, that's almost about it. There's of course a lot of infrastructure and supporting projects like the Nethermind API, which just is basically a facade for all of the like not a facade, but like a project where we collect all of the classes that are needed to operate the Nethermind client. And there is the init project that inits the client. It has the steps that initializes the client. So the client is basically, when the runner starts, it calls the init project to initialize the client, and there's steps, and steps depend on each other. So they run on sequence one by one until the client is fully initialized. So yeah, this is I guess a general idea of the important parts of the client and where potential like bugs need to be looked at. Um, what else, Tim, you think that we should cover here? Do you have any other suggestions?
I think what we should focus on is, what parts of the code you think are the most vulnerable, or at least like if you were the white hat, right? Where would you look in the first place, in the second place, like in the third place? Maybe some, general guidance here, or some useful tips for them.
Hmm. Hmm. Okay, so um, in reality, it's very vast. Like I mentioned, there is too many types of attack that could happen here. Um, but if I would focus on the most critical parts, I would say it's the EVM. So like a lot of attacks happen in this area. If we have anything wrong in the transaction processing part, so the transaction processor, for example, has a bug, this is a huge problem and could lead to like serious issues. There is also like of course, a virtual machine, transaction substate, all of like basically this project. This project is very, very critical, super critical, to be honest. Sometimes you wouldn't expect it, but a bug in traces could lead to issues in the VM. So like um, it's that critical. So this project is very, very, very critical. And I would also look into any math implementations that this project will depend on. So like in core, if you noticed, I have mentioned one of the dependencies, one of the dependency packages is actually int to 56, for example. And one time we found a bug that luckily did not happen on mainnet, but basically someone used a mod um on a very, very large number, and this led to an incorrect behavior for this library. And thankfully, someone found it and reported it secretly, and we fixed it. And it didn't lead to any forks. But if someone had exploited it before that happened, he would have created a fork in the network. So these are very, very critical. Anything basically that is crypto could have a small bug, an overflow, underflow. These kind of things are very, very critical, and used all over the client. So like Kachak, hash to 56, public keys, signatures, all of these. Yeah, so like honestly, there isn't really a way for me to highlight all of these areas because it's like the whole client is critical almost. It's especially the consensus part that I have mentioned. So any issues in these would lead to disasters. Um, that's why like the client always goes through like rigorous reviews before we release any update. Um,
Sure, sure. Sounds fair. I guess one other question would be, were there any audits done previously? And if yes, do you have a list of issues that were identified there?
no, not that I know of. I don't think Nethermind
Mhm.
has been audited before now.
I see.
Interestingly, neither
That's
did
even more
Geth.
interesting. Interesting.
As far as I know,
Okay.
even other execution clients didn't have audits. The only client that I think had audits until now was Reth because it's like more on the new side and it hasn't been used a lot. So they wanted to make sure that it's audited before people start using it. But since Nethermind is being used by a lot of people, almost um, a large number of people. Sometimes people might say like 40% of the network is using Nethermind. Then because of that, um, it's being audited live, basically on production because like it's battle tested. It's been used by a lot of people for a long time. Yeah.
Yep. Sounds fair too. Um, hmm. Let me think of any other possible questions here. Ahmad, any public-facing documentation that whiteheads
Oh,
can check out? Yep. Anything like that?
yeah. So there are docs.nethermind.io. So if you go there, um, the if you go to docs.nethermind.io, let me share my switch to sharing another window. So this one, and yeah. Um, so in the docs, you have the basic how to set things up. What are the configurations that you can set up the client with, etc. So how to interact with Nethermind, mm, how to have monitorings for it. So and there is also like a guide to how to create plugins and stuff like that. But other than that, there isn't really docs about how the code is written. We don't have that. Um, as far as I know, I haven't seen a lot of clients that have that. I don't know if any do actually. Um, but yeah, so there are docs. They are just for usage, not documenting the code base, unfortunately.
I mean, I think this is already something that we have here, more than enough, I'd say. That's fine. Ahmad, I think let me think a bit. Is there anything else that you think might be valuable to cover right now? Anything else to present or maybe point out? Because from my, from my standpoint, this is pretty solid as a presentation. Thank you.
Mm,
Anything else?
nothing that comes to mind, to be honest. I'm trying to think if there are anything. Yeah, focus. I would say focus on consensus. So I try to highlight the projects that have consensus that could lead to consensus issues. This is very critical. And then the other projects that could lead to DOS vector attacks. So these are the two attacks that I think are most critical and I would be very wary of. Um, yeah, just be mindful that any JSON RPC exhaustion does not count as DOS attack because JSON RPC is not a public facing RPC. This is used internally by the user. This is the assumption. So even if you DOS the client by just calling a lot of JSON RPC, this is not really an attack that we would consider as an attack. But if you can DOS the client with P2P requests, this is an attack that we would consider and we would take seriously. Um, what else? Yeah. So DOS vector on P2P and then also consensus issues. These are, I would advise people to go and look for these and try to check these out the most. Yeah. And that's all.
Makes sense. Well, then we can make it short and sweet. I think we can end here.
Yep.
Once again, Ahmed, thank you for the perfect presentation.
Hey, thank you,
Guys,
Tim.
yeah, for those who are watching this in the recording, who got to this point, Ethereum network Attackathon is active. It's going to be live till January 20th. Huge reward amounts up to 1.5 million. Go grab these bugs. Many projects in there, many functionalities. Good luck, everyone. So, thank you.